So if we kind of like have to start with answering the question, what's mobile good for and what's web good for, right? So usually mobile is used a lot for people who keep reusing the same services over and over again. And like statistically, people actually spend like almost 20 times longer using mobile applications than they do with web applications. So basically, mobile apps are really good. Like if you live in a city and there's like an app that shows you all the buses and underground, etc. So you'll be using this app all over and over again, right? However, web is really good for the reach. Like web can reach a lot more people. So web usually will have a lot more users than mobile applications. And for example, where web is very good is you fly into Amsterdam and you want to go to Van Gogh's museum, and you're not going to download an application just to buy the tickets once. It's kind of silly, right? So in that case, you have a web application. But also, if you live in Amsterdam and you're a big fan of Van Gogh, you might want to go there every day. So maybe you should have a mobile application, or maybe you should have both. So in reality, it's not about one versus the other, but it's pretty much like Luke Wróblewski said, is kind of like use the web for the audience reach and use mobile, for the great experience and for people that keep coming back to you, right? So the whole thing is like you shouldn't need to choose. You should try actually to target both. And in 99% of the cases, you should have both. Okay, so our aim for today is basically use Angular so that we could target web, Android, and iOS applications. Okay, so how do we do that? So we kind of like created NativeScript about 3 years ago. We released like version 1.0, and then we talked with the guys from the Angular team, and they said like we work in Angular too, and we think that NativeScript could be a very good fit for it. So that was pretty much May 2015. We kind of started working together. And then a year later, we had a NativeScript integration with Angular. So just for you, like in case you haven't heard about NativeScript before, it's an open source framework that allows you to use JavaScript or TypeScript or Angular or actually even Vue as of recently to build mobile applications with native UIs, right? And it's very much like a React Native, but slightly different. Like you can use Angular with it, or Vue, or just vanilla JavaScript. So let's have a look at one example. Imagine you wanted to create a login page. And so in that login page, you would already have some sort of a user service. If we create a component, we could inject that user service into a component, and then we could expose like a couple of functions like the login and sign up that would call the service, right? The exact code is not super important. And the cool thing is that the code for the service or the code for the component is completely platform agnostic. How you call the HTTP service doesn't really specify whether this is a web application, desktop, or if it's a Hoover, right? It's when it becomes a web application is when we add the HTML. So when you add the HTML and you have this template, so you could, for example, have an input, and you can bind the ng model to user email, or as well another one input where we bind to user password. Then we have a couple of buttons, so one that calls login and another one that calls sign up. And that basically turns that service with the component and this HTML into a web application, right? But then if you want to do the same thing with NativeScript, we could actually reuse the same service, the same component, but it would just have a different HTML. So the idea is that yeah, we wouldn't use necessarily an input, but we would use a text field that again binds to user email, and another one that would bind to user password. So we bind into the same properties. And also we would have a couple of buttons. So we have a login button and a sign up button. And in this case, we don't bind to click, but we bind to tap events because you don't click on phones, right? That would be kind of weird, unless you want to click with a pen or something. So that's pretty much the idea, right? Like you can share those services and components, but the HTML will be different because that's where the real difference is. So let's have a look at some of the key differences between Angular web projects and NativeScript projects in general with Angular. So one of them is like the project structure. So the Angular project usually sits within source app code. Our code usually sits within app code. And we have like some other small differences in terms of how we arrange our projects. which could be a bit of a challenge when you want to do code sharing. Another one is there's the two different sets of build tools. So with Angular, use Angular CLI. With NativeScript, we have NativeScript CLI that can perform, the native builds either using Xcode or use Gradle to build your Android applications. Okay, but then one of the biggest differences really is in the UI, where your web components and the styling will be different between the two. Okay, so this is kind of like a big picture of what sort of things are shareable or kind of or not. So for example, if you look at the bottom, come here. Nope, doesn't work. If we look at the bottom, we have the CSS or your Sass styling. So we would have two separate CSS files between web and mobile, but then they can both kind of derive from a common Sass where you could set up the theme for all of your applications. And actually, one of my side projects I'm working on, for example, uses Angular material that I have one common theme for mobile and web using the material kind of theming. So that's one of the parts. The other part where this application will be different is, again, the HTML, which is the markup. But then we get to share all the HTTP services, the Angular service, all the components, pipe, routes, directives. You can actually share all of those between the application. So it's kind of we have to look at it as okay, how can we get these bits and then make them work together, and then how can we split these bits apart and then make it work? That's pretty much the challenge for today. So in a way, we're kind of looking okay, we should be able to share most of our TypeScript code, most of the Angular pieces, and most of our Sass. All right. So what are the possible solutions? There are kind of two approaches, right? I'll start with the simple one, which is the multiple projects. So imagine you have this folder, a shared folder, which has all those Angular pieces that are shareable, services, components, etc. Then separately, you could create two projects. So you'd create this project with Angular CLI, you would create this one with NativeScript CLI. So you have two separate projects, and then you move this folder inside each of those. So this is the identical copy of the two. And then finally, you can basically implement your web application and your mobile application. So this will be where you have the web-specific or mobile-specific code, right? So this is one of the ways of doing it. And if you look at the pros and cons, pretty much this approach is easy to set up. It's pretty good for small projects, and there is no learning curve. Because if you independently know how to build an application with Angular Web or with NativeScript Angular, then you have those skills. You don't have to kind of think of how do I cross between the two, right? But then the bad thing is that the code duplication is pretty bad, and this application doesn't scale. So basically, it's fine if you have 3 or 4 components, but as soon as you grow to 10 or 20 or more, copying and pasting across is just not going to cut the chase, right? You could come up with some automated builds and everything is just not going to work. So basically, the ugly part is the maintenance, where as soon as you want to grow this application, it's not necessarily going to work. So for proof of concept, yeah, go ahead and do it. If you want to build a bigger application, that's the second approach, which is the monorepo. So the idea is that we have one big project that has everything, right? So we have all our pipe services, all of it together. But for example, we have our Sass variables, and then 2 style sheets, one for web, one for NativeScript that they derive from that Sass. Then you'd have all your components here. So all the components would, for example, share the TypeScript code, but then they'll have separate HTML files. And then finally, you would also have your modules, which would share the components, share the navigation, but then would have 2 separate ng modules because you might want to import different things. And I think you already got the theme that anything that is white is shared, blue and red is for specific platforms, right? So we have this monorepo. We have this project where everything is in there. So what do we do next? Well, next thing we need is basically some sort of a build process that can take these pieces, and when we want to build a web application, you take the shared code and a web specific and then build an Angular application. Or if we want a mobile application, you should take the shared and a NativeScript code and then give us a NativeScript app. So like a native iOS or native Android application. All right. So again, the pros and cons. So the good part is you can actually use Angular CLI with it to generate all your pipes or your services, etc., which is pretty great. It's really good for complex projects, and because everything is in one place, you kind of you don't have to be jumping between two different places. Like everything is here, is pretty clear what is what. You don't have problems with synchronization, right? The bad thing is it is a bit of overkill for small projects. So if we go back to the project where you just had 2 pages, this is going to be a bit too much. And the fact that you need this additional build process can be a little bit daunting, because you're like, okay, I can put all those pieces here, but how the hell do I build all of that, right? So it's just like, how do I even start? That's usually the ugly part, okay? So let's answer that part. Luckily for us, there's a bunch of project seeds that have been created that already answer this to us, right? One is from Nathan Walker. It's called the Advanced Angular seed, which I don't have a slide for it now. And the other one is a lot simpler. It's from Team Maestro. It's called Angular Native seed. So you can basically just clone this GitHub repo and then use it as your own, and then start building it on top of it. And I really, really recommend using that. And later on, I'll do a demo, and I'll show you how to use it. So if we use this, basically the mono repo from Angular Native seed kind of works like this if you want to build the application. If you want to build a web application using this mono repo, it's business as usual. Basically, you just call ngserve, which will run it through Angular CLI, which basically builds the web application. Nothing new. If you want to build a mobile application, there is a custom build for it, okay? So what really happens is, usually when you build applications with NativeScript, you for example, say tns run iOS, right? The tns is the Telerik NativeScript command. In this case, the custom build runs the npm command, and it does it in 2 steps. The first step, it runs a gulp process, which looks at the mono repo and says, okay, here are the shared files, here are the NativeScript ones. I'm going to go and restructure a NativeScript project. So it basically recreates a NativeScript project structure from it. And then as a second step, it goes through the NativeScript CLI and builds the mobile application. So automatically this runs over here, TNS run iOS or Android for us. So it's kind of like all of that is sorted out for us. And then when you want to build a component, so how do we do that? Like, what is the naming convention, etc.? So if you have component kind of like name component, you have 3 files. We have name.component.ts for the shared file. Then for the web, we would have name.component.html. So far, so good. But to make a file NativeScript specific, we just add this .tns over here. So we have a file called name.component.tns.html. So and another thing we can do is like, okay, we want to add styling. Then we can basically add name.component SCSS, and then another one, name.component.tns SCSS. And then basically that's how you split it. And the cool thing is that basically if I didn't have this file, then this file would become shared. So by the virtue of me adding a .tns, I'm saying actually I have 2 versions here. Which basically is the thing. Like if I wanted to have 2 versions of this, I could just create another file with .tns, and then now have 2 versions, which is plain simple. And that works for any file that exists within the project structure. So there are obviously some challenges within building a code-sharing application, and I want to take you through a few of them. So one of them is the library API mismatch. So imagine you might have some sort of library that is developed separately for web and separately for NativeScript, and they will have different APIs, right? So, and then there's 2 ways to kind of challenge it. You can challenge it by creating like a common service. So you kind of resolve it at the application level, or you could do it through a higher abstraction. So you could create a wrapper around the library before you start creating your services. So let me give you an example. So the service abstraction, imagine we have a new cloud database. Let's call it PigeonDB, okay? So the PigeonDB would have 2 separate plugins, one for web, one for NativeScript, with completely different APIs. What you can do then is basically create two separate web services. So then you would have, let's say, data service.ts and data service.tns.ts, right? So we have two different files. And then those will basically implement the same business logic, but calling different APIs. But these two services would expose the same functions, right? So you would have like a common service interface. So automatically all your components that use this service then basically could call this data service, right? So that's one approach. Another approach, which is kind of, if you're planning to keep reusing the same service abstraction in different projects, it's kind of more of an investment. And that's basically where you take these two plugins and you create like a plugin wrapper. So you create two plugin wrappers, which basically expose the same functionality to a common API. And then you can build your data services with one business logic, and then all the components can call that data service, right? So I actually use this for the example I'm going to talk about next. So here's one example where I kind of got on it. Like I built a demo application, and I realized that Angular Fire 2 for Firebase basically looked completely different to the one we had in NativeScript. Okay, and then so I had few of the issues that I had to deal with. One of them is there were two completely separate user models. Like they were almost the same, but they were different, right? You know, like for example, okay, all those, when I logged in and I got the user, all the users would have UID, email, verified email, and refresh token, perfect. But then for name, I would have either display name or name, photo URL or photo image URL. And that's already a problem. Like if I want to return an attribute and bind to it in HTML, I should have just one common way of looking at them, right? So pretty much the solution for something like that is basically define a unified model, create a parser, and then whenever you get the user model, like the data, you just parse it into always the common user model. So this is like a code snippet from my project, where I created like a Firebase user with, I said, okay, this should be the fields that I should have in my data whenever I return a user model. And then whenever, for example, I want to parse it, basically I pass in, and that's a NativeScript example, I pass in like a user object from, which is the NativeScript user, and I basically assign individual attributes. So for example, here is anonymous, I'm actually drawing from user.anonymous, right? On and on. And then I have the same parser for the web. So that, for example, later on, when I call login, so I call firebase.login, when I get the result, which is the user, I always return this dot parse user, and then I pass that user. And the problem's solved, right? So then later on, anyone that uses this service goes just sign in, and you always get the same type, regardless whether it is a web or a mobile application. Another problem, and that was a lot bigger, and I didn't see that coming initially. So Angular Fire 2 is built completely with observables. The NativeScript plugin, the author of that plugin created it with listeners. So like the whole concept was completely different. It's like not only returning slightly different data, it's like literally the whole workflow is out of the window, right? So my solution was basically, oh, that's not the solution yet. Yeah, that basically, this is how I was looking like. So this is like the web code, this is the NativeScript code. So in order to get data here, I just called like the Angular database.object, pass a path, and I'll get observable. In NativeScript, I had to call add value event listener. So like handling that is completely different. So the solution really was for me, take that listener and convert it into an observable, okay? So I had this function which was basically prepare object observable, which returns an observable, all right? So inside here, I basically call add value event listener. And then when that happens, I basically get like a listeners object, which I can use later on to stop listening when I need to, all right? We'll get to there. Then inside, whenever this listener returns, I basically take my subscriber from the observable and just call next. So whenever a listener gets me data, I just call next, and I make this behave like an observable. And then finally, when somebody unsubscribes from this observable, I basically remove event listeners. So I stop listening to this specific node. And voila, like this becomes my observable now. So now if anyone uses my abstraction, they can use this library as observables and work both the same. Another challenge is around some of the extensions that we created for NativeScript. So I'll show you an example. So in NativeScript, so you see like, you all know how to do navigation with Angular, where you could just call this.router.navigate, you can provide a path, and then that will navigate to another piece of code. But NativeScript has some additional properties. So because I'm on a mobile application, I can provide a transition. So when I navigate, for example, the page can flip, or could do some sliding, or do some of the UX that you would have on a mobile application. So the way we do it is, well, you can provide an optional parameter like transition, etc. However, if I run this code through web, basically TypeScript is just going to go crazy. It's like, whoa, this property shouldn't be here. Basically, it's just going to throw the thing out of the window. So it's like, that's it, I'm done. So again, like it's like, okay, so we are looking now at two solutions. Like, should I split this TypeScript file into two files, and then whenever I need to navigate, have two files? Or should I kind of create like some sort of abstraction? So this was my answer. Like, I created basically a service that was just purely for navigation, and I had one version of service that was, let's say, service.ts and service.tns.ts, right? So the NativeScript one was just like a pure wrapper, but then the one for the web, I added additional properties like clear history, animated, and transitions. Like, so I added all these missing attributes. And then basically I had two navigation services. So the web one was able to take these additional parameters, but then when we pass them here, Angular is going to ignore them anyway, so there's no harm. It might be a little bit confusing for somebody looking at the code. It's like, well, it says flip, but it's not flipping on the website. It's just like, yeah, but at least it doesn't complain, you know? While for NativeScript, it's just like a pure copy of the same code. So it's just like a workaround around TypeScript. I could have just added a tag, say like just ignore it, but I think it's a more elegant way of doing it. Cool. So basically, then I can have one shareable component. So if I have our login, in our login I can call this navigation service.navigate, and I can provide a path and then some additional parameters. And if I call this, it's going to work both nicely on the web and mobile without complaining. Yeah, on web it's not going to clear the history because that's not possible in the browser, but on NativeScript, it will stop you from pressing the back button so that you can navigate to the login page. You don't want that. Cool. Another challenge, different modules. So here's one story. So one of the demos I wanted to build, I wanted to have some like an endless scrolling, right? So I have a data object that has like 10,000 items, and if I run ng4 on that, it's just gonna kill the memory of my application, right? I mean, Chrome already takes a lot, and give it 10,000 objects is gonna be even worse. But the thing is that for web, basically, there is this npm module which is called ngx infinite scroll that you can import, but that's just a web module, right? So if I went and installed it, but in order to add it, I had to have like two separate ng modules, right? So in the web ng module, we would have all the shared code, all the shared modules that they both have. So for example, this shared would have the navigation service. They will both have it, right? But then separately, I would have some additional unique, oops, go back. As a button miss, actually this one doesn't need it. So this one, for example, would have the additional unique module, which would be the endless scrolling module from before. So basically, this is the web ng module, which has the infinite scroll module over here. And then I can, call something like this so that I can add like 10 items every time I reach the bottom. And then for NativeScript, I'll have all the same imports, but I wouldn't have that infinite module over there, right? So this way I can actually have like more specific modules between one and the other. because in case of NativeScript, I have a list view that has the load more items event that does it for me anyway. Cool. So there's actually a few more examples that I sometimes show depending on time. But I think this kind of illustrates some of the major challenges that we would normally have. And one of the things I was showing you is like, okay, so with code sharing, you can create all those services, all those modules. But if you create a module and you have all these 2 versions of ng module, then you have 2 different files for HTML, 2 different files for CSS. All of a sudden, just to create a simple module, 1 component, you have like 10 files. Right? And it's kind of like, yeah, but I need 20 modules. It's like you spend a whole day just creating the files. So Angular CLI, as much as it can generate the web structure for you, it wouldn't necessarily create the .tns files for you, right? So what I did is actually I created an extension to the NativeScript CLI, which basically you can install it by calling tns extension install NativeScript Angular CLI, and that mimics the Angular CLI's behavior with some extended functionality. This is more like a beta so far, but it works, right? So some of the commands that you can use is like tns generate shared component, and you can give it a name, or for short tns gsc and give it a name. And then this will generate a component that will have the .tns files and then the one we found with some of the boilerplate already. And then as well, you have generate shared module. So this will already import some of the important files and then scaffold the whole application for you, which is pretty cool. And like I'll show you how I use it in a moment. So that's the idea. There's one more thing. Actually, this extension works even if you don't use NativeScript CLI. If you don't use code sharing. So if you do just tns generate component, you would just do the NativeScript only without the web. One more thing. Oh yeah, so this NativeScript Angular CLI was specifically for the code sharing, created for the Team Maestro project seed. So it's not going to work with the other ones as well, but with the Team Maestro, I can guarantee work pretty well. So it's the demo time. So I have a couple of things to show. Cool. So before anyone asks about slides, because that always happens, if you follow me on Twitter, I just tweeted my slides. So you can go and get them. That's the easy part. So let's see what we have here. I hope you can all see the code. So what I did already, I ran the command which basically goes somewhere, doesn't matter, which basically goes like tns run iOS, just runs in the background. It takes like half a minute, but I can save time. And basically that builds the application and it deployed it to an iOS simulator for me. And now every time I make change to the code, so like changed, it will go and refresh the application over here pretty quickly. So that's a cool thing. So I just want to show you some basic stuff we can do with Angular. That's not code sharing just yet. So if you know Angular, like, okay, so I have hard-coded text, but maybe I just want to bind it to a property. So in my TypeScript class, I have a message property saying hello Munich. Or I could add some styling. So class, make it h1. Yeah, that should do it. And then the text should be more visible. And let's center it. So I can set text center. So that kind of shows you some of the CSS stuff we can do. Another thing is like we can create our own CSS. So we have this warning flag or warning class, which basically sets the color to orange-red. So rather than just hard-code it to that class, I could create a property like all good, which is a Boolean. And let's set it to false for now. And then I'll have a function called do something. Is that how you spell it? More or less. Which basically would take all good and then set it to the opposite value. Nice and simple, all right? So we can now do something else. So I'm going to add a button, and there are pretty cool code snippets for VS Code that you could just install. And I'm going to call do something here. Yeah, let's even say here. Why not? And I am going to call this function. So on top event, I'm going to call do something. And then additionally, on this label, I am going to add a conditional class. So it's a class.message. And I want to set it to this to be enabled when all good is not good, right? When it's false. So let's save that. Something went wrong. It's not message, it's warning. See? It's not fake, it's real stuff. So now I can kind of change between the two. Also, I don't like this button. It looks a bit ugly, so I'm gonna style it quickly. Button. I'm not a designer, so this is as far as I go, all right? But at least the button kind of looks a bit better. We can also use animations. So I could, for example, do something like this. So I can add some keyframes. So I can set like a keyframes for zoom, and I'm running through few transitions. So I can first scale it to like 50% of the size, then after 40% of time to like 160%, and then at the end I want to set it to normal size. So what I'm going to do is like make it small, big, normal, okay? And then once we have that, basically in my class, I'm setting the animation name to zoom, and then I want to run it over 2 seconds. And to add to the effect, I am going to create a bunch of these labels, because that looks cool. Make them different size. And see what happens. Oops. And then save this SAS file. And kind of like, you can see how they like go bigger and smaller. The other thing is that we can also use like pre-built animations. And this also works with Angular animations if you want to do that. I actually did some recording on that recently. So I have this animate.css file. So I got it from this guy. I literally went online and like started Googling for people with animations and stuff. So this one has like the bounce animation, or like bouncing left and some other animations. So I literally downloaded the CSS file, add it to my project, and I could do something like this. So I can change from the zoom to maybe rubber band. So it's kind of gonna go like squish and quash, bouncing left, and then I can kind of keep replaying it. And then finally, we have just bounce. So that's when you go to a party, you can just bounce. So that's another thing. And then one other thing that NativeScript is really great is when we have the native plugins. So one of the big benefits is like in NativeScript, you actually get direct access to the native API from JavaScript. So if there is a function or type that exists on the Android API or iOS API, you can literally call it from JavaScript. And that basically meant that we have a lot of plugin authors that create plugins. So we have this site called market.nativescript.org where you can find all our plugins, or you can even search for them on NPM. So there's this NativeScript color picker, okay? So this one is pretty cool. So what I can do with this one is this. So first I'm gonna import like the color picker and a color property. Then I'm gonna add some attributes. So I'm creating a new instance of the color picker. I'm setting like a default selected color to gray. And then finally I have this function that basically shows the color picker. We're using the default value. And then when the user selects a color, I'm just updating the selected color. Okay? So let me go back to the HTML. And I'm gonna change background if I could spell color to, all right, copy and paste is faster than spelling sometimes. Oops. This is when you keep switching between Windows and Macs. Copy and paste works in a different way. All right, you can do something here, and I am gonna call show color picker. All right, so this is gray for the beginning. And you see this actually pops up a native color picker. And now it's green. I can change it. Now it's red, etc. And that's pretty cool because this is a native iOS component that is popping up with me just writing a few lines of code. And then finally, I just want to show you quick navigations. Not this one. So one of the things we could do is like, I have like a different route. So there's another page called MIP, which allows me to navigate to that page. So I can, for example, set page transition to like curl, fade, slide bottom, or flip. Actually, not this. So curl, I can kind of curl in, fade, slide. And you can see it actually comes back from where it went, and flip, etc. So these are the kind of stuff we can do, which you get with very little effort. If you know Angular, you pretty much can build mobile applications. That's the really cool stuff. I was gonna show you how to build an app for the robot, but I'll probably run out of time, and I wanna show you how to do the code sharing, which is the point of today. But if you wanna stay for another hour, I'll show you how to do the robot. Just saying. All right. Let's kill this. So code sharing. So I created this demo application. Oh, this is my material design project. Wrong. Pet Bros. Yeah. So there's this API that allows me to basically look for pets that you can adopt in the US. You know, you can look for cats, for horses, for pigs, if Christmas is coming, etc. But anyway, so I thought that like this is going to be a perfect code sharing project. So out of the box, you get like this project structure, and then the source is basically the folder where you write all your code. The NativeScript folder is, you almost never go here. This is the folder that gets recreated whenever Gulp is running and then finding the right files. But one place that you might want to go here for is for package.json. So here's where we have our build scripts and also NativeScript specific NPM modules that we might want to add. So there's 2 package.jsons. But outside of that, you almost never go to this folder. So our application is pretty much in source app, and this is where we write our code. So for example, I have my Firebase implementation here, and I have my Firebase module, which has like Firebase data user, user service, etc. So like this is where I create that extension. But let me just run the apps quickly so that you know what to expect. So I'm gonna run 2 terminals. So one, I can just run ngserve, and that should open the application for me. And the other one, I have to go into the NativeScript folder, and I will run npm run iOS. Oh, I am already running some web application somewhere. Let's try again. Cool. So I repeat, I'm not a designer. The whole thing is that it should work. Yeah. All right, webpack compiled build. Cool, so this is my web application, which has like a login page, so I can log in, and I use Firebase to have like my favorite pets. This is actually using Angular material, and you know, like I can go check the Bandit and Mischief, or maybe not, or Snickers, And then kind of you get even some more details. So these are real pets you can adopt. This is not fake data, right? And then there's like a search page also where I can go, okay, I want to look for animals. Let's see. We want to look for horses type. There's a donkey. Yeah, let's look for donkeys, young donkeys. And these are donkeys you can adopt in Boston. You can, read about them. It's running a little bit slow, but that's not the point. It's Wi-Fi, yeah. But it kind of, or you can look just for all the pets, and you get the idea. Let's see. So the NativeScript are built already as well. So we have a login page. So I can, for example, log in, and these are the same favorite pets that I had. So I'm gonna add, let's say, Topaz. Topaz looks nice, and Topaz should appear somewhere on the list. So they all use Firebase. I have too many pets that I want. Trooper, Lulu, there is Topaz. I can go, check the details once it loads. That's not the point. But this is the cool things. Like I'm basically sharing those. So if I, for example, look at the code, let's have a look at the login component. So for the login component, you see here I have one login component.ts, and I have two HTML files, which are the two main things. So this component imports the user service and also the navigation service. And then on login, I'm basically taking the user service, and if the login details are valid, I'm just calling user service.signin, which goes to the Firebase to verify. And if all is good, then I'm navigating to home and clearing the history. Or for registration, I can do the same, but I allow users to provide password and display name. And then basically, I just have two HTML files. One we use Angular Material to capture the input, and then provide some details, and the other one we use NativeScript UI for it. That's pretty much the magic. And if I come back to the user service very quickly, in here, the user service, what does it do? In a constructor, I need to find a constructor. Yeah, in the constructor, I'm actually injecting the Firebase user service and the Firebase data service, which is my abstraction. And then, for example, when you want to sign in, it just uses the Firebase user service to sign in for you. So it's kind of like propagating. But it's basically just one service to do all the signing, to log out, to reset password. It does everything in one place. It's just the HTML that's different. So if I wanted to, I'm going to open my Firebase. Oh, yeah, it was there. Pet Bros. So that's my Firebase database. And I have like a bunch of petters. So people who want to pet the pets, okay? So let's have a look how we can create a quick page that could access this data and display that will work for both. So I'm gonna kill the build process here. Actually, I'm gonna kill both of them. So I'm gonna first, we already have the service, so I'm gonna say TNS generate shared module. I'm gonna call petter. And then if you look here, this generated this folder petter. So in here, first of all, we have one root file. So if we added more components to this module, then we could add more roots to this specific module. And then additionally, we have the module.ts and module.tns, where we can specify the specific modules for both of them. All right. Then additionally, here we have a petter component. So with that petter component, basically, this is where we can start implementing our application. So let's do that. So I'm gonna import the Firebase data service and Firebase list, and I'm gonna inject the data service, which is Firebase data service over here, and maybe we'll have some data like patterns, which is unobservable. Let's import this of type pattern. So let's import that too. I think that comes from there. Cool. And inside my ng on init, I'm basically just, actually I can do it in constructor, because why not? I can say this patterns equals data service dot, it's a list of data of type pattern. And the path to it, if I remember, is just basically slash patterns. So this will return like a list, Firebase list object, and then basically all I need to do is call value changes, which returns unobservable. And I just realized that this observable each time returns an array of objects. So that's pretty much all I needed to get the patterns. Okay. So the next thing is, okay, let's go and implement our HTML. So how do we do that? So how about we just create a new div and run a quick ng4, and we're gonna go, okay, let pet of patterns $, because that's an observable, and I'm gonna use an async pipe. And then for each of them, I can, for example, display pattern dot. Oh, all right, let's see what attributes we have. It's actually a we have a TypeScript definition. So we have name. Let's display name and email. Okay, that should do. So let's display name and email. Oh, pattern. Cool. So that's the first part, and we're gonna do something similar for NativeScript. Do I want to use ng4? I guess I can use ng4. I should use a list view, but can't be bothered. So pretty much, let's create a new stack layout for each of those. ng4. And then I'm gonna add ns label, and basically I will just display now, you know what, I'm gonna create a list view. Sorry, it's just bad habit to do it otherwise or other way. Okay, so our data source, let's make it smaller, is basically patterns, which is an async, and I'm gonna call let pattern of item, and then for each of them I'll have pattern.name and pattern.email. Yeah, that's a lot prettier. Cool. So I just created so I have a TypeScript class, I've got an HTML, I have a way to read the data. The final thing is that I need to add this to the navigation. So in this project, if I go to the app routes, this is where I have all my navigation. So I can add another lazy loaded path. So the path would be, we navigate to pattern. So we will go to app pattern, and then find the app pattern.module file, and then extract the pattern module. So this is how you do lazy loading. And just to simplify it, by default, I'm just gonna change the redirect to pattern, so that we just arrive there without having to log in. Cool. So hopefully, if I didn't mess up, this should work for web. There's also live sync that I could technically use, but let's let it build. So my expectation now is that I should be able to go to this /pattern And you see, it kind of printed out Gerard the hero a@abc.com, which is the data here. I could change it to bc.com. It should refresh it. So that's how I did for the web. And then NativeScript is still building. I have way too many Chrome stuff open, so it's just taking a little while. Normally it's a bit faster. Did it rebuild? Let's see. Oh, damn it. See, this is the old habit of me running TNS. I was supposed to run npm run iOS. So it's all planned. It was on purpose. All right. So when that builds, we'll see a new page. I should display some new data. And obviously, like, if I had more time, like, we could literally build it so we would have like one edit page that will work for both, and etc. But it's just kind of like this, just to show you how we can load exactly the same data, how we can make it, you know, with live reloads and everything, and then how little of the difference there really is. So let's see. The application restarts. The drum roll. Come on. And here we are. So we have a list view which has like Gerard the hero, B@ABC, Nathan, and like we have all this data, all the same data. I just forgot to make the list view so that it appears on the whole page. Rookie mistake. Height 100%. I can let it build, but that's not exactly the point. And you can see like some of the design changes, because that was even on purpose. That, for example, in this application, I have like the top navigation, but in my mobile app, I actually didn't want it. Right? Technically, what I could do, like if I wanted, maybe I would want something that I could slide, or maybe could have a hamburger that kind of opens navigation, etc. So the fact that you could make all of it identical, like it doesn't have to be identical. You can have slightly different designs for each of those. Now the app should build quicker. So we should be able to see the whole data. And after that's done, there you go. So now we have a list view that shows exactly the same data. And then if I change it over here, it kind of, you see, instantaneously updates. So Gerard can actually handle 50. Oh, I'm not doing pets. Gerard the hero. Oh, I'm updating the wrong field. The superhero. And it kind of instantaneously updates, which is pretty amazing. And it works on both of them at the same time. So that, I think that is really, really powerful. Obviously, you can do more than that. So let me just go through a few slides, and you can probably ask some questions, and maybe I can show you how to play with the robot. Some of the goals we have, because the code sharing is like my personal project as well within our company. So one of the things is like I want to create an integration directly with the Angular CLI. So that's something that we'll be working on towards the end of this year. So with all schematics and everything that is coming up, like this should be super easy to do. So I'm already talking to Hans about that. Move away from the gulp process. So the problem with gulp at the moment we have is it can restructure the project for us from everything that is inside source. But if I wanted to publish my Firebase abstraction so that it would work for both, I can't do it as an NPM module because gulp is not going to go in there. So we could modify gulp, but that's not really the point. What we probably want to do is move this into Webpack so that Webpack could actually do all that decisions for me. And then even get rid of having a separate build folder for NativeScript, but always everything should be built within the source. So Webpack is going to basically help us do that. And we already have some prototypes around that and some ideas. And then technically what you should be able to do is just run ngserve, and then this will build web and mobile applications at the same time with live sync and everything instantaneously available, which is basically something you should be able to see early next year. and then have a migration process. So what I showed you so far is, hey, you want to build an application? Here's a repo. You can start with it. But if you come to me and say, hey, I have an web application, I want to build a code sharing application with NativeScript as well, we don't have like an official story on how to do it yet. So what I want to do is say, if you want to do it, come to me and I'll help you. But we don't have like official documentation on saying, here are the 5 key steps you have to do to migrate from web to a code sharing project. But we'll get there. Especially once we have the integration with the Angular CLI, it's going to be super easy. And then we're trying to build more real-life examples. So the example I showed you before, like you can actually check it on GitHub. So if you check github/sebavita/petbros, that's basically that example is a real with real data and it's working there. But we want to build more of those. So I want to build one that uses Salesforce and has like an e-commerce application. And also I'm working on some workshop materials. So if you want to learn how to do it hands-on, probably early next year, I might come back to Munich and we could do like a whole day workshop on doing that. At the moment, I can do it ad hoc, but I want to create like some real materials that you could even do by yourself. So that's pretty much me. So if you have any questions, I also have t-shirts. You helped me at the beginning. What size are you? You're extra small, right? I was just kidding. But yeah. If you ask questions, you can get t-shirts. And I have limited sizes. So let's see. Yes, did you see that? All the years of practice of giving t-shirts for good questions. Who wants? There you go.
You said about 2 options when you put your code into different projects. Or in one project, but share it all the stuff. But did you consider the third option, like create separate NPM repository for common structure and just work with that? YARN link or NPM link is really simple to work.
Sure, but then you still would have 2 separate projects.
Yes, but with this link function, it will be like one.
Yeah, I mean, that could be a good way. So funny you actually say that because when I created, when I was initially playing with the pet service, I created an Angular service for it, which I wrapped the REST API, and that is basically just what you described, a service that works both for NativeScript and web. So yeah, that is one of the good techniques on how you could do that.
With your current project, you can have a problem with the size. What if you want to web application, but not mobile yet? You still have something mobile, but you have this web application. You have to support several branches, and you can have less.
Yeah, you're making a very good point, but at the same time, I can turn it around. Is what if you just want to release everything simultaneously? So if you have separation, you might be that you implement it here, but then later on you have to merge it there. So it's kind of... Sure. Sure, I've been on project like that. No, but exactly, these are basically something that we have to consider. There's like 2 ways. So actually, yeah, you're making very good points. So if you have 2 separate projects, another benefit you could move at different pace, which is a good point. I'll add it to my pros and cons. What size are you? You're medium. All right, I got medium here. Where did you go? Oh, there you go. Oh, no, we're still doing questions. There you go. Mm-hmm.
And a friend of mine actually figured that they had the bug with the direct messages that you could swipe 3 of them and have all 3 of them stuck. So, and that feature is actually removed from Android. So how often you get this issue?
Mm-hmm.
And the second question is, what if I want to use Canvas, but for one part of the application, I just want to create some kind of animation in Canvas? Is that supported like through the web view or something? How should I, for example, do that?
Okay, so I can answer the Canvas first because that's kind of easier. So don't have Canvas API ready. We're trying to figure out a good way to create like a polyfill for it. And it's not going to be available this year. We're hoping to have it sometime early next year. But basically, we don't have Canvas support as of yet. And yes, you could add a web view to NativeScript. But it's more good for like if you want to display some website. But I wouldn't use it extensively because basically you're doing Ionic and you're defeating the whole purpose. So for now, Canvas, I would say it's not an option. In terms of things possibly going wrong when you have iOS and Android in the UI, is actually something that is different in the approaches we have between React Native and NativeScript. So with React, you still kind of, React Native, you still have to build two separate UIs. You separate build iOS and separate Android UI. In NativeScript, you build that UI once. So like you were seeing me, I wasn't writing iOS UI with NativeScript. I was building the NativeScript UI. So issues like that, you will see a lot less. So we're trying to cover all the common bits that you have together on Android and iOS. And then if there's something specific to one platform, you can as well like add additional option. So for example, if you want to do the, I don't know what it's called on iOS, but you can kind of have the press that is either light press or strong press. You could actually add a function to say on light press, which will get ignored on Android, but it will work on iOS. But in terms of issues that we see between two different platforms, we don't see them like very often. Like that's something very, very rare. One of the things is like for any of you that is into testing as well, we created like we use Dev Appium internally. We have like a few thousand tests. And we continuously on every pull request on pretty much any code change, we just run all of those. So we have like thousands of tests where we run the application. We have an image of what we expect. We build the application, run it, and if we see the image, we do like pixel by pixel comparisons. So we should not see many of those issues. UB, large, right? Medium? Yes. Yes to the last one, right? Yeah, that's large. There you go. Any more questions? I know you asked 2 questions, just 1 T-shirt.
How do you debug NativeScript?
I can actually debugging. That's a great question. You should get 2 T-shirts. He's planted. No, seriously. So basically, there's a command for it, and which project is this? I want to do it on this one. So what I can do is basically I can run TNS, run debug, if I could spell, and I can even add Chrome. I'm not sure if this project is ready for it, and I'll just do without Chrome. So for Android, by default, we would use Chrome DevTools, and if I upgrade this TNS debug iOS. Oh. Sorry, yeah. Long day. Hopefully this will work Chrome. So basically by running this command, I will be able to open this application in Chrome DevTools, put a breakpoint just like you do in a web browser. Let's put my ridiculously long password. My machine is super slow today. But basically, once that opens, I could put all the breakpoints and stuff. Oh, yeah. So what files did we have? Not this project. This project. So we had show color picker, and that's in getting started. Okay. I didn't upgrade this project. All right, I'm just gonna run it for Android and just run on my phone. That'll be better. Don't do it. TNS, debug, Android. Yeah, that would be better. Sorry, because the Chrome support we only added to the latest release, and I realized that I didn't upgrade my projects yet to this project to the latest release. But for Android, we had it for quite a while already. So, oops. How hard is it to highlight and copy? There we go. Getting, oh, actually, I already have it here. So I can put breakpoint, and if I press getting started, you see I have breakpoint here, and I can even step over and then kind of like see what's happening step by step. I also have console. So after I selected color, you see I got back, I have the result. I could even change result to, 600, and now it will be 600, etc. So you can even, call functions from here. So I can call alert, hello from dev Chrome tools. And if I run that, oh yeah, it kind of like, I even have a pop-up on my phone. So, and like this has like the network tab, so you could check any HTTP request. You have the elements tab as well. You have the memory tab, so you can kind of like check all the performance and everything. So I could even like modify my UI from the elements tab live, and then see how the styling etc. changes. So let's get you a T-shirt. This are you extra large? There you go. I have 2XL. Is there somebody very big that wants 2XL T-shirt? You're not 2XL. Come on. But you can ask a testing. Yeah.
How it's possible to test? Because general application, web application, you can test like with Selenium or like you test kind of that stuff. How it's possible to test it?
So basically, so for unit tests, you should be able to use Selenium. So I'm not a tester, that's like the difficult part for me. But basically, all your services and components, etc., like you could test it with Selenium. The moment you want to start testing the UI part, or what kind of appears on the screen, then you can use the native, what did I say before? Appium, Dev Appium, NativeScript Dev Appium. So there's a really cool talk from, let me see if I can find it, from NativeScript Developer Day. Yeah, so we had a conference. So I'm going to post a link. One of the talks was on testing with Appium. And the guys basically from our team, like our testers that created the NativeScript extension, they talk about how to use it and everything. It's literally in 15 minutes you can learn how to set up your UI testing there. So that might be something worth looking. So I don't know the exact answers, these guys do. Although I spent days with them preparing that talk. Let's see, I'm running out of sizes. So this is large. Is large okay?
I think so.
Unless you want, I have small, you're not small. Luckily you're not a girl, you won't get offended. Anyone else? Free t-shirts? No? All right, in that case, thanks for listening, and have a good day.